My name is Renell Samuel. I was head of building for Murray & Dixon Construction, and I was contract director on this job. So the Plaatje library is quite a unique building. It's in the heart of the university and actually brings all the surrounding buildings together. It's the centerpiece. It's like the jewel of the campus. And it's a quite unusual building because it's mainly made up of concrete and steel. So where the outer skin of the building is actually floating 2.4 meters off the ground, held up by steel columns attached to the side wall of the concrete structure. The inner frame of the building is also separated from the outer walls and is connected by steel frame as well. The entire building has sloping roofs and it's quite spectacular. It's probably the first and only and last time I'll do something quite as amazing as this building. So I was involved from stage 3 design. It's not normal where a contractor is involved at that stage, but when we work on the NEC target cost framework contract, we are quite involved from design stage right to completion. So I spent probably 18 months on design and development, costing on this contract before we actually commenced work on site. So that was quite unique, and it was a lot of interaction with the designers, namely the architects and the engineers, as to the buildability of the entire building. And while we're talking about steel, how the steel was actually going to work and all the details, especially with the connections with the concrete and the interface as a whole. The steel was actually critical to the entire building. So firstly, from the floating concrete, 2.4 meters off the ground, which is quite spectacular. As you see, the entire structure, it's a 7-story building. So the entire building looks like it's floating off the ground. And then all the connections, so the outer walls are connected to the inner slabs. The roof of the building is connected to the outer walls. And the courtyard itself, there is a large opening with steel structure, with light penetration. Even the glass facades on the outer skin of the building is connected to the inner slabs with steel. The staircases that are in between the slabs and the wall are all seamless and floating again, hanging from the roof of the building. So, and that was structural steel. Which was a bit of a nightmare to get in, but it's amazing the way it works and it looks. So, I mean, the stairs, for instance, it's hanging off the roof, the roof is between 5 stories and 7 stories high. And in order to get the staircases in, we had to complete the bulk of the structure and then manually maneuver the staircases in and get the first one, which is on the top floor, in first, off hangers, and then bring each one in afterwards. In the time frame and how it was done, it was a miracle, but it worked out well. 0 fatalities, and it came out amazing. I think the casting elements were key to the job, and understanding it had to be placed to a millimeter to tie into the structure. If it wasn't done that way, everything would be misaligned, and you'd see large gaps in your steel, and the structure wouldn't work at all. So that was done to the millimeter, and fortunately for us, it worked out well. I think the teamwork on the project and the intricate detail, just looking at it, you don't see all the detail on the job, all the connections, all the casting items. So there's a huge amount of casting steel items on this contract that needed to be done 100%. For the structure to work. The entire concrete and steel structure all interacts together, and without each component working 100%, the entire building could fail. So the devil's in the detail on this job, and I'm proud of my team and the entire design team and the client for making this happen. Again, it's probably the first and last time I'll ever do it, and I'm proud to be part of it.